Question 1. Following the identification of an elevated level of a specific allergen in a finished product batch, a food manufacturer implemented a revised allergen segregation protocol and enhanced staff training on allergen handling procedures. As the lead implementer, what is the most critical aspect to focus on when monitoring the effectiveness of these improvement actions to ensure compliance with ISO 22018 requirements and relevant regulatory mandates such as the EU General Food Law Regulation, EC, No. 178/2002? Option A. Documenting the root cause analysis for the initial allergen deviation in the internal audit report. Option B. Verifying that the revised allergen segregation protocol is consistently applied and that subsequent product testing confirms the absence of the identified allergen above acceptable limits. Option C. Reviewing the cost savings achieved by the new segregation protocol compared to the previous one. Option D. Confirming that all employees have signed off on the updated allergen handling training materials. Correct answer is B. Verifying that the revised allergen segregation protocol is consistently applied and that subsequent product testing confirms the absence of the identified allergen above acceptable limits. Explanation. The core principle of monitoring the effectiveness of improvement actions within an ISO 22018 framework, particularly for a lead implementer, involves verifying that the implemented corrective or preventive measures have indeed resolved the identified nonconformity or potential hazard and have not introduced new risks. This requires a systematic approach that goes beyond simply observing that an action was taken. It necessitates the collection of objective evidence to demonstrate the sustained achievement of the intended outcome. This evidence can come from various sources, including re-audits, performance monitoring of key food safety indicators, customer feedback analysis, and review of operational records. The objective is to confirm that the root cause has been addressed and that the food safety management system is operating as intended with the improvements integrated. For instance, if a process deviation led to a microbial contamination issue, an improvement action might involve recalibrating equipment or revising a cleaning procedure. Monitoring effectiveness would then involve testing the product after the recalibration or observing the revised procedure in practice and analyzing subsequent test results to confirm the absence of contamination. This iterative process of monitoring and verification is crucial for the continuous improvement mandated by the standard. Question 2. A multinational food processing company, AgriHarvest Foods, specializing in ready-to-eat meals, is undergoing its initial ISO 22018 certification audit. The company operates in several countries with varying national food safety regulations and consumer expectations regarding allergens. AgriHarvest Foods has also recently invested in advanced automation for its packaging lines, which has introduced new potential contamination pathways not previously considered. During the context of the organization review, the audit team identifies that the FSMS documentation primarily focuses on the company's internal operational procedures and quality control measures, with limited explicit consideration given to the diverse international regulatory landscape and the evolving consumer concerns about novel food ingredients used in their products. Which aspect of understanding the organization and its context, as per ISO 22018, has AgriHarvest Foods inadequately addressed in its FSMS development? Option A. Failure to sufficiently consider external issues that impact the organization's ability to achieve its food safety objectives, including diverse regulatory environments and evolving consumer demands. Option B. Overlooking the need to establish measurable food safety objectives for the ready-to-eat meal product line. Option C. Insufficient internal process mapping of the new automated packaging lines and their impact on CCPs. Option D. Inadequate assessment of the organization's financial resources available for food safety initiatives. The correct answer is A. Failure to sufficiently consider external issues that impact the organization's ability to achieve its food safety objectives, including diverse regulatory environments and evolving consumer demands. Explanation. The organization's context, as defined in ISO 22018 Clause 4. 1. Involves understanding external and internal issues relevant to its purpose and strategic direction, and that affect its ability to achieve the intended results of its food safety management system. This understanding is foundational for establishing the scope of the FSMS and for determining food safety policy and objectives. External issues can include regulatory requirements, such as EU Regulation 178/2002, laying down general principles and requirements of food law, establishing the European Food Safety Authority, and laying down procedures in matters of food safety or national food safety legislation. Market trends, technological advancements, and socio-economic factors. Internal issues encompass the organization's culture, resources, processes, and capabilities. A comprehensive analysis of these factors allows the organization to identify potential opportunities for improvement and risks that need to be managed. For instance, a new international trade agreement that imposes stricter import standards for certain food products would be a critical external issue requiring consideration within the FSMS context. Similarly, a recent internal audit revealing inconsistencies in critical control point monitoring procedures would be a significant internal issue. The interplay of these issues directly influences the design and effectiveness of the food safety management system, ensuring its alignment with the organization's overall business strategy and its commitment to delivering safe food. Question 3. AgriHarvest Foods, a producer of prepackaged salads, has observed a significant uptick in customer complaints regarding premature spoilage, correlating with an increased incidence of microbial growth. Their food safety team has gathered data on internal refrigeration temperatures, ingredient pH levels, and the efficacy of their modified atmosphere packaging (MAP) process. Considering the principles of ISO 22000-2018, which analytical approach would be most effective for AgriHarvest Foods to identify the root cause and guide corrective actions related to this escalating spoilage issue? Option A. A statistical review of all operational data, including production batch numbers and staff training records, without prioritizing specific control measures. Option B. An isolated evaluation of the refrigeration system's temperature logs to determine if any excursions fall outside the established critical limits. Option C. A trend analysis of MAP gas composition fluctuations against recorded instances of spoilage, cross-referenced with the performance of refrigeration units and ingredient pH stability data. Option D. A comparative analysis of customer complaint logs from the past 5 years, focusing solely on the frequency of spoilage-related feedback. The correct answer is C. A trend analysis of MAP gas composition fluctuations against recorded instances of spoilage, cross-referenced with the performance of refrigeration units and ingredient pH stability data. Explanation: the scenario describes a food processing company, AgriHarvest Foods, that produces packaged salads. They are facing an increase in customer complaints related to spoilage, specifically identifying a higher than acceptable incidence of microbial growth in their products. The company's food safety team has collected data on various parameters, including refrigeration temperatures during storage and transport, pH levels of the salad ingredients, and the effectiveness of their modified atmosphere packaging (MAP) process. The ISO 22000-2018 standard emphasizes the importance of data-driven decision-making and the use of monitoring and measurement results to assess the performance of the food safety management system. Clause 9. 1. Monitoring, measurement, analysis, and evaluation requires organizations to determine what needs to be monitored and measured. The methods for monitoring, measurement, analysis, and evaluation needed to ensure valid results, when the monitoring and measurement should be performed, and when the results from monitoring and measurement should be analyzed and evaluated. The analysis of the collected data should not just identify the problem, but also link it to the effectiveness of the implemented control measures. In this case, while refrigeration temperatures and pH are critical control points, the increased spoilage suggests a potential breakdown or inadequacy in the MAP process, which is a critical control measure for extending shelf life and preventing microbial proliferation. Therefore, a thorough analysis should focus on the efficacy of the MAP system in relation to the observed spoilage trends, considering factors like gas composition, seal integrity, and the specified shelf life parameters. This aligns with the standard's requirement to evaluate the performance of controls and make necessary adjustments to maintain food safety. Question 4. Consider a food processing facility manufacturing a ready-to-eat product where a pasteurization step is implemented to control the hazard of vegetative pathogens. During the hack plan development, the team identifies this pasteurization step. Which of the following statements best reflects the application of the decision tree principles to classify this control point as a critical control point, CCP, according to ISO 22000-2018? Option A. The pasteurization step is classified as a CCP because it is designed to eliminate or reduce a significant food safety hazard to an acceptable level, and without this control, the hazard is likely to occur at an unacceptable level. Option B. The pasteurization step is classified as a CCP if it is the only control measure implemented in the entire process to manage the identified hazard, regardless of its effectiveness. Option C. The pasteurization step is classified as a CCP if it is performed by a trained operator who has documented their adherence to the standard operating procedure for pasteurization. Option D. The pasteurization step is classified as a CCP because it is a mandatory step in the production process, as dictated by national food safety regulations. The correct answer is A. The pasteurization step is classified as a CCP because it is designed to eliminate or reduce a significant food safety hazard to an acceptable level, and without this control, the hazard is likely to occur at an unacceptable level. Explanation. The core of implementing ISO 22000-2018, particularly concerning hazard analysis and critical control points, HACC principles, involves a systematic approach to identifying, evaluating, and controlling food safety hazards. The decision tree is a crucial tool used during the HACC plan development to determine whether a control point is a critical control point, CCP. The decision tree is a series of yes/no questions designed to guide the HACC team. The first question typically asks if the identified control point addresses a food safety hazard. If the answer is no, it is not a CCP. If the answer is yes, the subsequent questions focus on the likelihood of the hazard occurring and the severity of its potential consequences if not controlled. Specifically, a control point becomes a CCP if it is essential for preventing or eliminating a food safety hazard or reducing it to an acceptable level. This is determined by a sequence of logical inquiries about the hazard's significance and the effectiveness of the control measure. The objective is to isolate those points in the process where intervention is absolutely necessary to ensure food safety. Question 5. A food business specializing in ready-to-eat meals has established a robust HACC plan identifying critical control points for microbial growth during cooking and cooling. As a lead implementer for ISO 22000-2018, you are reviewing the effectiveness of their verification activities. The business conducts regular internal audits of their cooking and cooling procedures, reviews CCP monitoring records daily, and performs monthly external laboratory testing of finished products for indicator organisms. Which of the following verification activities, when performed as part of a comprehensive verification program, most directly confirms that the implemented control measures are operating as intended and are effective in achieving the desired food safety outcomes according to ISO 22000-2018? Option A. Reviewing the calibration records for the temperature probes used at the cooking and cooling CCPs and comparing them against the recorded monitoring data for consistency. Option B. Conducting a hazard analysis review to identify any new or emerging biological hazards that may require additional control measures. Option C. Evaluating the effectiveness of the prerequisite programs in preventing cross-contamination during ingredient receiving and storage. Option D. Analyzing customer complaint data to identify any recurring issues related to product spoilage or potential contamination. The correct answer is A. Reviewing the calibration records for the temperature probes used at the cooking and cooling CCPs and comparing them against the recorded monitoring data for consistency. Explanation. ISO 22000-2018, in its Clause 8.5.1, outlines the requirements for verification. Verification activities are distinct from validation. Validation confirms that the control measures and their implementation are capable of controlling the identified food safety hazards. Verification, on the other hand, confirms that the food safety management system is functioning as intended and that the implemented control measures are effectively achieving the intended results. This involves a range of activities such as audits, reviews of records, and analysis of performance data. For a food business producing prepackaged salads, a key verification activity would be to confirm that the critical control points, CCP, identified in their hack plan are consistently monitored, and that the recorded data accurately reflects the process parameters. For instance, if chilling temperature is a CCP, verification would involve reviewing temperature logs, calibration records for thermometers, and potentially conducting independent temperature checks to ensure the system is operating as designed and documented. This is crucial for demonstrating that the established food safety controls are indeed in place and effective in preventing or reducing food safety hazards to acceptable levels, thereby ensuring the overall integrity of the food safety management system. Question 6. A global supplier of processed fruits and vegetables, operating under varying national food safety regulations and serving diverse markets, is initiating the implementation of an ISO 22000-2018 FSMS. The organization's management seeks to establish a robust system that addresses the unique food safety challenges presented by its varied product portfolio, including fresh-cut produce, frozen fruits, and canned vegetables, across its 3 distinct processing facilities located in different countries. What foundational step is most critical for effectively defining the boundaries and desired outcomes of this FSMS implementation? Option A. Clearly articulate the intended coverage of the FSMS, encompassing specific product categories, processing stages, and operational sites, while simultaneously establishing measurable food safety objectives aligned with identified risks and applicable regulatory requirements. Option B. Develop a detailed quality management system that focuses primarily on product consistency and customer satisfaction, with food safety aspects being addressed as a secondary consideration within the overall operational framework. Option C. Prioritize the acquisition of relevant certifications for each facility independently, focusing on national standards before integrating them into a unified ISO 22000-2018 framework to ensure market-specific compliance. Option D. Conduct a comprehensive HACCP study for each product line, irrespective of the FSMS scope, to identify all potential hazards and establish preliminary control measures before formalizing the system's objectives. The correct answer is A. Clearly articulate the intended coverage of the FSMS, encompassing specific product categories, processing stages, and operational sites, while simultaneously establishing measurable food safety objectives aligned with identified risks and applicable regulatory requirements. Explanation. The core of defining the scope and objectives for an ISO 22000-2018 Food Safety Management System, FSMS, implementation lies in establishing clear boundaries and measurable outcomes that align with the organization's context, legal requirements, and stakeholder expectations. The scope dictates which products, processes, sites, and activities are covered by the FSMS. Objectives, on the other hand, provide specific, measurable, achievable, relevant, and time-bound, SMART targets for improving food safety performance. For a multinational food ingredient manufacturer with diverse product lines and multiple processing facilities across different regulatory jurisdictions, the scope must explicitly define the boundaries of the FSMS. This includes specifying the types of ingredients produced, the specific manufacturing sites included, and the particular stages of the supply chain that are within the organization's control and influence. Concurrently, objectives should be set to address identified food safety hazards and risks, such as reducing the incidence of specific microbial contamination by a certain percentage within a defined timeframe, or ensuring 100% compliance with new EU regulations on allergen labeling for all relevant products within 6 months of their enforcement. The interplay between these elements is crucial for a successful and effective FSMS implementation, ensuring that the system addresses the most critical food safety aspects relevant to the organization's operations and its commitment to providing safe food. Question 7. A food manufacturer is introducing a novel raw vegetable ingredient sourced from a new supplier for a ready-to-eat salad product. Preliminary testing indicates a potential for sporadic low-level contamination with Salmonella spp, which is a recognized pathogen with a high severity of illness. The planned processing sequence involves washing, cutting, and then a mild blanching step before packaging. The hazard analysis team is deliberating on the most effective control strategy, which approach best aligns with the principles of hazard analysis and control measure selection as outlined in ISO 22000-2018 for this scenario. Option A. focus exclusively on enhanced visual inspection and sorting of the raw vegetables to remove any visibly contaminated material before further processing. Option B. Implement a validated thermal inactivation step for the raw vegetable ingredient upon receipt, coupled with stringent supplier verification of their own hazard control measures. Option C. Document the potential for Salmonella SBP. As a hazard but deem it non-significant due to the subsequent blanching step, without implementing a specific control measure at receipt or during blanching. Option D. Rely solely on the mild blanching step in the downstream processing to reduce Salmonella SBP to acceptable levels, assuming it will effectively eliminate the hazard. The correct answer is B. Implement a validated thermal inactivation step for the raw vegetable ingredient upon receipt, coupled with stringent supplier verification of their own hazard control measures. Explanation: the core of hazard analysis in ISO 22000-2018 involves identifying, evaluating, and selecting control measures to manage food safety hazards. And considering a new ingredient with potential for microbial contamination, a lead implementer must first understand the nature of the hazard and its likely occurrence. The standard emphasizes a systematic approach, which includes considering the intended use of the food and the potential for misuse. For a raw ingredient intended for further processing, the likelihood of a hazard persisting or multiplying during subsequent steps is a critical factor. Evaluating the severity of the hazard, such as the potential for severe illness or death, is also paramount. Selection of control measures should be based on their effectiveness in reducing the hazard to an acceptable level, considering the feasibility of implementation and verification. A control measure that relies solely on a subsequent processing step, especially if that step is not fully validated or controlled for this specific hazard, would be considered less robust than a measure applied directly to the ingredient itself or a more reliable control during the initial processing. Therefore, implementing a control measure at the point of receipt, such as a validated inactivation step or a stringent supplier assurance program with verified critical control points at their facility, would be a more proactive and effective approach than relying on a later, potentially less controlled processing stage. The concept of acceptable level is defined by the organization's food safety policy and objectives, often informed by regulatory requirements. For instance, if a raw ingredient can harbor pathogenic bacteria like Listeria monocytogenes and the subsequent processing involves a mild heat treatment that might not guarantee an activation, a control measure applied earlier is crucial. The decision on whether a hazard is significant and requires a control measure is based on the hazard analysis team's assessment of likelihood and severity, aligned with the organization's risk tolerance. Question 8. Gourmet Grains Inc., a producer of specialty flours and grains, has identified a recurring pattern of minor deviations related to allergen cross-contamination during the packaging of their certified gluten-free oat product. These deviations, while not leading to a non-conforming product release, are noted in internal audits and product traceability records. The FSMS lead implementer is tasked with ensuring continual improvement in this area. Following the implementation of new cleaning protocols and enhanced staff training on allergen segregation, what is the most critical next step to demonstrate the effectiveness of these implemented actions and fulfill the requirements of ISO 22000-2018 for continual improvement? Option A. Conduct a comprehensive risk assessment of all packaging lines to identify potential new hazards. Option B. Update the FSMS documentation to reflect the new cleaning protocols and training procedures. Option C. Verify the effectiveness of the implemented corrective actions through targeted monitoring and auditing. Option D. Initiate a review of the entire allergen control program, including raw material sourcing. The correct answer is C. Verify the effectiveness of the implemented corrective actions through targeted monitoring and auditing. Explanation: the core of implementing continual improvement within an ISO 22000-2018 Food Safety Management System, FSMS, lies in a structured, data-driven approach. Clause 10. 2. Continual improvement mandates that an organization shall continually improve the suitability, adequacy, and effectiveness of the FSMS. This involves using the outputs from audits, performance evaluations, corrective actions, and management reviews to identify opportunities for enhancement. When a food processing facility, such as Gourmet Grains Inc., identifies recurring deviations in their hazard analysis and critical control points, HACCP plan implementation, specifically concerning the control of allergen cross-contamination during the packaging of gluten-free oats. A systematic process is required. This process should involve analyzing the root cause of these deviations, which might stem from inadequate training, equipment calibration issues, or procedural adherence problems. Following root cause analysis, corrective actions must be implemented to address the identified issues. Crucially, the effectiveness of these corrective actions needs to be verified. This verification step is paramount for ensuring that the implemented changes actually resolve the problem and do not introduce new hazards or inefficiencies. The ISO 22000-2018 standard emphasizes the PDCA, Plan Do Check Act, cycle as a framework for improvement. In this scenario, the check phase involves evaluating the impact of the corrective actions on the allergen cross-contamination issue. This evaluation would typically involve re-auditing the process, monitoring critical control points, and analyzing incident reports. If the corrective actions prove effective, they are then acted upon by integrating them into standard operating procedures, updating training materials, and potentially revising the HACCP plan. If the actions are not effective, the cycle restarts with a deeper investigation into the root cause or alternative corrective actions. Therefore, the most appropriate action for Gourmet Grains Inc. to take immediately after implementing corrective actions for allergen cross-contamination is to verify their effectiveness to ensure the FSMS is continually improved. Question 9. A food manufacturer producing ready-to-eat meals has recently experienced a situation where a critical control point, CCP, for pasteurization failed to maintain the required temperature for a sustained period, potentially compromising the microbial safety of several product batches. The organization's food safety team is evaluating the effectiveness of their emergency preparedness and response plan. Which of the following actions best demonstrates a comprehensive and compliant response to this incident, aligning with ISO 22000-2018 principles and general food safety regulatory expectations? Option A. Isolate the affected batches and await further instructions from regulatory authorities before taking any containment or communication actions, focusing solely on immediate equipment repair. Option B. Immediately initiate a full recall of all potentially affected batches, conduct a thorough root cause analysis of the CCP failure, implement immediate corrective actions to rectify the pasteurization process, and notify relevant regulatory bodies and distribution partners as per the documented communication plan. Option C. Inform the sales team about the potential issue and instruct them to handle customer inquiries on a case-by-case basis, while the Quality Assurance Department investigates the deviation without external notification unless legally compelled. Option D. Conduct an internal review of the pasteurization process to identify potential causes, document the temperature deviation in the operational records, and resume production after recalibrating the equipment, assuming no immediate customer complaints are received. The correct answer is B. Immediately initiate a full recall of all potentially affected batches, conduct a thorough root cause analysis of the CCP failure, implement immediate corrective actions to rectify the pasteurization process, and notify relevant regulatory bodies and distribution partners as per the documented communication plan. Explanation. The effectiveness of an emergency preparedness and response plan under ISO 22000-2018 hinges on its ability to anticipate, manage, and recover from food safety incidents. Clause 8.4. Control of nonconformities and Clause 8.3. Emergency preparedness and response are central here. A food safety incident by its nature is a nonconformity that could potentially escalate. The plan must therefore integrate immediate containment actions, communication protocols, and a structured approach to investigation and corrective action. Considering a scenario where a batch of prepackaged salads is suspected of containing a known allergen not declared on the label, a robust plan would first involve immediate isolation of the affected product to prevent further distribution and consumption. This aligns with the principle of controlling nonconformities by preventing unintended use or delivery. Subsequently, communication with relevant authorities, as mandated by food safety legislation, which varies by jurisdiction but generally requires reporting of significant food safety issues, and with affected customers or retailers is crucial. The investigation phase would aim to identify the root cause of the mislabeling, whether it was a raw material issue, a processing error, or a packaging defect. The response would then focus on implementing corrective and preventive actions to eliminate the cause and prevent recurrence, such as enhanced allergen control procedures, improved labeling verification processes, or supplier audits. The plan's validation and review are also critical to ensure its ongoing suitability and effectiveness. Therefore, the most comprehensive and effective approach is to have a documented plan that specifically addresses the identification, containment, communication, investigation, and correction of food safety incidents, ensuring alignment with both the standards requirements and applicable regulatory obligations. Question 10. Consider a large-scale food processing facility that has identified a significant emerging risk related to a novel pathogen strain not previously cataloged in regulatory databases, potentially impacting their ready-to-eat product line. Concurrently, they have identified an opportunity to gain a competitive advantage by implementing a new blockchain-based traceability system that promises enhanced transparency and faster recall management. As the lead implementer, what is the most strategic approach to integrating the management of these identified risks and opportunities into the existing ISO 22000-2018 Food Safety Management System? Option A. Develop specific, measurable, achievable, relevant, and time-bound, smart action plans for both the pathogen risk mitigation and the blockchain implementation, ensuring these plans are documented, assigned responsibility, and integrated into the relevant operational control procedures and management review processes. Option B. Conduct a thorough hazard analysis for the novel pathogen, updating prerequisite programs and operational prerequisite programs, OPUP, as necessary, and simultaneously initiate a pilot project for the blockchain traceability system to assess its feasibility and impact on risk management. Option C. Prioritize the pathogen risk by immediately halting production of the affected product line and initiating a comprehensive supplier audit, while deferring the blockchain implementation until the pathogen issue is fully resolved and a robust business case can be presented. Option D. Establish a dedicated cross-functional task force to investigate the novel pathogen and explore potential control measures, while commissioning an external consultancy to design and implement the blockchain traceability system, with progress reports submitted quarterly to top management. The correct answer is A. Develop specific, measurable, achievable, relevant, and time-bound, smart action plans for both the pathogen risk mitigation and the blockchain implementation, ensuring these plans are documented, assigned responsibility, and integrated into the relevant operational control procedures and management review processes. Explanation. The core principle of addressing risks and opportunities within ISO 22000-2018 is to ensure the food safety management system achieves its intended outcomes and prevents undesirable effects. This involves a proactive approach to identifying potential deviations from planned results and capitalizing on favorable conditions. Clause 8.2.1 General of ISO 22000-2018 mandates that the organization shall plan and control the processes needed to meet the requirements for the provision of safe food and to implement actions to address risks and opportunities. The standard further elaborates in Clause 6.1 Actions to address risks and opportunities, that the organization shall determine the risks and opportunities related to the food safety management system and its ability to achieve the intended results and plan actions to address them. These actions must be integrated into the food safety management system processes and evaluated for their effectiveness. The focus is on ensuring that potential hazards are controlled and opportunities for improvement are leveraged to enhance food safety performance and the overall effectiveness of the system. This includes considering both threats that could compromise food safety and positive potential that could enhance it, such as improved process efficiency or new market opportunities related to superior food safety credentials. The planning for these actions must consider the context of the organization, its objectives, and the identified food safety hazards and control measures. Question 11. When evaluating the robustness of an organization's prerequisite programs, PRP, under ISO 22000-2018, which of the following areas, if inadequately controlled, would most likely necessitate a fundamental reevaluation and potential overhaul of multiple PRPs due to its pervasive impact on the entire production environment and the high likelihood of cross-contamination across diverse product lines? Option A. Ineffective pest control measures leading to the introduction of biological contaminants into the processing areas. Option B. Inadequate verification of a single critical raw material's compliance with specified quality parameters. Option C. Insufficient documentation of employee training records for a particular processing step. Option D. Inconsistent application of cleaning and sanitization protocols for specific processing equipment used for a single product batch. The correct answer is A. Ineffective pest control measures leading to the introduction of biological contaminants into the processing areas. Explanation: the effectiveness of prerequisite programs, PRP, is foundational to a robust food safety management system, FSMS, as outlined in ISO 22000-2018. PRPs establish the basic environmental and operational conditions necessary to produce safe food. Clause 8 of ISO 22000-2018 details the requirements for PRPs, emphasizing their role in controlling food safety hazards. When assessing the adequacy of PRPs, a lead implementer must consider how well these programs address potential contamination sources and control mechanisms across the entire food chain. The question probes the understanding of which specific area, when inadequately controlled by PRPs, poses the most significant systemic risk to food safety, requiring a broader scope of corrective action beyond immediate product handling. This involves understanding that issues in the broader operational environment can have pervasive and difficult-to-contain consequences, impacting multiple stages of production and product lines. Therefore, the control of the immediate production environment, encompassing factors like facility design, sanitation, and pest control, is paramount. Weaknesses in these areas can lead to widespread contamination that is challenging to isolate and rectify, necessitating a comprehensive review and enhancement of the entire PRP framework, rather than just specific operational procedures. The direct impact of an uncontrolled external biological or chemical contamination source entering the production facility through inadequate building integrity or pest management would necessitate a broad reassessment and likely a temporary halt to operations for comprehensive remediation, affecting all products processed within that environment. This is a more systemic failure than issues with individual processing steps or raw material verification, which can often be managed through targeted CCPs or OPA. Question 12. A food safety team at AgriHarvest Foods, a company specializing in prepackaged salads, is conducting a hazard analysis for a new product line incorporating imported leafy greens. They have identified a potential hazard of microbial contamination, e.g., Listeria monocytogenes, on the greens and a chemical hazard related to undeclared allergens, e.g., peanut traces from cross-contamination in the shared processing facility. As the lead implementer, how should the team prioritize the focus of control measures when evaluating the combined risk profile of these two distinct hazards, considering that regulatory limits for Listeria are stringent and the likelihood of cross-contamination with allergens is influenced by the effectiveness of cleaning protocols and employee training? Option A. Implement a one-size-fits-all approach to control measures, applying the same level of rigor to both hazards regardless of their individual risk profiles, to ensure consistency across the food safety management system. Option B. Focus solely on the microbial hazard as it presents a more immediate and potentially widespread public health threat, assuming allergen controls are adequately covered by general hygiene practices. Option C. Address the allergen hazard first due to its direct link to specific consumer sensitivities and potential for severe, immediate reactions, even if the probability of contamination is lower than the microbial hazard. Option D. Prioritize control measures based on a comprehensive risk assessment that considers the potential severity of illness from Listeria and the allergenic reaction severity, alongside the probability of occurrence for each, to determine the most effective combination of CCPs and OPA. The correct answer is D. Prioritize control measures based on a comprehensive risk assessment that considers the potential severity of illness from Listeria and the allergenic reaction severity, alongside the probability of occurrence for each, to determine the most effective combination of CCPs and OPA. Explanation: the core of hazard assessment in ISO 22000-2018 involves evaluating both the likelihood of a hazard occurring and the potential severity of its consequences. This evaluation is not a simple calculation, but a systematic process of risk characterization. When considering a scenario where a food processing plant has identified a potential biological hazard, e.g., salmonella in raw poultry, and a chemical hazard, e.g., excessive pesticide residue on imported vegetables, the lead implementer must guide the team in determining the appropriate control measures. Severity of a biological hazard like salmonella can range from mild gastrointestinal distress to severe illness or even death, depending on the pathogen's virulence and the consumer's susceptibility. The probability of its occurrence is influenced by factors such as the source of the poultry, hygiene practices during processing, and storage conditions. Similarly, the severity of excessive pesticide residue depends on the specific pesticide, the level of contamination, and the acceptable daily intake, ADI, established by regulatory bodies. The probability is linked to agricultural practices, washing procedures, and quality control checks on incoming raw materials. ISO 22018 emphasizes that the risk assessment should be based on available scientific information and expert judgment. The outcome of this assessment directly informs the selection of critical control points, CCP, or operational prerequisite programs, OPP, and the establishment of acceptance criteria. A hazard with high severity and high probability would typically require stringent control measures and continuous monitoring, whereas a hazard with low severity and low probability might be managed through less intensive controls or even accepted if deemed negligible. The process is iterative and should be reviewed and updated as new information becomes available or processing conditions change. Question 13. A food processing facility implementing ISO 22018 has established a digital system for managing all food safety records, including CCP monitoring logs, supplier verification documents, and internal audit reports. During an internal audit, it was noted that several critical records, such as those detailing corrective actions for a detected pathogen, could be accessed and modified by any employee with network access, regardless of their role or department. What is the most appropriate action for the food safety team, guided by the principles of ISO 22018, to address this deficiency in controlling documented information? Option A. Archive all digital food safety records in a secure, offline location, requiring a formal request process for any employee needing to access historical data. Option B. Conduct a comprehensive training session for all employees on the importance of data integrity for food safety records, relying on their professional judgment to protect sensitive information. Option C. Implement role-based access controls within the digital system, ensuring that only designated personnel have the authority to view, edit, or approve specific categories of food safety records based on their responsibilities. Option D. Develop a new paper-based system for all critical food safety records, storing them in a locked filing cabinet accessible only by the quality assurance manager. Correct answer is C. Implement role-based access controls within the digital system, ensuring that only designated personnel have the authority to view, edit, or approve specific categories of food safety records based on their responsibilities. Explanation: ISO 22018 Clause 7. 5. 3. Control of documented information specifies requirements for controlling documented information, which includes records. Standard mandates that organizations establish processes for identification, storage, protection, retrieval, retention, and disposition of records. Controlling access to records is a critical aspect of their protection, ensuring that only authorized personnel can view, modify, or delete them. This is vital for maintaining data integrity, confidentiality, and compliance with regulatory requirements, such as those pertaining to traceability and product recalls. For example, records related to critical control points, CCP, or prerequisite programs, PRP, must be protected from unauthorized alteration to ensure the reliability of the food safety system. The lead implementer must ensure that the organization's procedures for record management align with these requirements, considering factors like digital security measures, physical security for paper records, and defined roles and responsibilities for record custodianship. The objective is to prevent accidental or malicious alteration or loss of vital food safety information. Question 14. An auditor reviewing the FSMS of a dairy processing plant, Lacta Fresh, identifies that while the plant has established CCPs for milk pasteurization and cooling, The calibration records for the temperature probes used at these critical points are inconsistent, with some entries dating back over 2 years. LactaFresh operates under stringent national food safety regulations that mandate regular verification of all equipment used for critical parameter monitoring. Which of the following resource management practices is most critical for LactaFresh to address to ensure compliance with ISO 22000, 2018 and relevant regulations? Option A. Establishing and adhering to a documented calibration and verification schedule for all monitoring and measuring equipment used to control food safety hazards. Option B. Implementing a robust system for supplier approval and monitoring of raw material quality to ensure incoming ingredients meet safety specifications. Option C. Developing a detailed training program for all personnel involved in food handling, focusing on hygiene practices and allergen control. Option D. Conducting a comprehensive risk assessment of all infrastructure, including refrigeration units and processing lines, to identify potential failure points. Correct answer is A. Establishing and adhering to a documented calibration and verification schedule for all monitoring and measuring equipment used to control food safety hazards. Explanation. The question pertains to the critical aspect of resources within an ISO 22000, 2018 Food Safety Management System, FSMS, specifically focusing on the monitoring and measuring equipment required to ensure the effectiveness of control measures. Clause 7, 2, 3 of ISO 22000, 2018 mandates that the organization shall determine and provide the resources needed for the establishment, implementation, maintenance, and continual improvement of the FSMS. This includes ensuring that monitoring and measuring equipment is suitable for its intended purpose, calibrated or verified at specified intervals, and maintained to ensure its continued fitness for purpose. The identification of specific equipment like calibrated thermometers and pH meters is crucial for verifying the effectiveness of critical control points, CCP, or operational prerequisite programs, OPP. For instance, in a pasteurization process, a calibrated thermometer is essential to ensure the minimum temperature and time requirements are met to eliminate harmful microorganisms. Similarly, for controlling spoilage in certain food products, monitoring pH levels with a verified pH meter is vital. The selection and maintenance of such equipment directly impact the reliability of the data used to confirm that food is safe for consumption and that the FSMS is operating as intended, aligning with the principles of HACCP and prerequisite programs. The ability to ensure the accuracy and reliability of these instruments is a fundamental requirement for demonstrating compliance and achieving food safety objectives. Question 15. When evaluating the integration of the Codex Alimentarius General Principles of Food Hygiene, CXC 1-1969, with ISO 22000-2018 for a multinational food processing company specializing in ready-to-eat meals, which statement best encapsulates the synergistic relationship and operational alignment between these two frameworks? Option A. ISO 22000, 2018 mandates adherence to specific Codex codes of practice for each product category, rendering Codex principles merely a checklist for compliance. Option B. The Codex General Principles of Food Hygiene are superseded by ISO 22000, 2018, with the latter focusing solely on internal operational controls and disregarding external supply chain influences. Option C. Codex Alimentarius Principles offer a foundational risk-based philosophy that informs the structured, systematic requirements of ISO 22000, 2018 for managing food safety throughout the supply chain. Option D. Codex Alimentarius Principles are primarily advisory and lack the scientific rigor to be directly integrated into a formal ISO 22000, 2018 food safety management system. The correct answer is C. Codex Alimentarius Principles offer a foundational, risk-based philosophy that informs the structured, systematic requirements of ISO 22000, 2018 for managing food safety throughout the supply chain. Explanation. The Codex Alimentarius General Principles of Food Hygiene, CXC 1-1969, provides a foundational framework for food safety management systems, aligning closely with the principles embedded within ISO 22000-2018. Specifically, the Codex principles emphasize a science-based approach to food safety, the importance of risk assessment and management, and the need for a comprehensive system that covers all stages of the food chain. ISO 22000, 2018 integrates these concepts by requiring organizations to establish, implement, maintain, and continually improve a food safety management system. This includes identifying potential food safety hazards, assessing their likelihood and severity, and implementing control measures, often identified through HACCP principles, which are themselves derived from Codex recommendations. The Codex principles also highlight the importance of prerequisite programs, PRP, as the foundation for HACCP, which translates to the operational prerequisite programs OPUP and prerequisite programs PRP, required by ISO 22000-2018. The standard further mandates communication, management commitment, and verification activities, all of which are implicit or explicit in the broader guidance provided by Codex. Therefore, the most accurate description of the relationship is that Codex Alimentarius principles provide the overarching scientific and risk-based philosophy that underpins the structured requirements of ISO 22000-2018 for establishing and maintaining an effective food safety management system across the entire food supply chain. Question 16. A food manufacturing company operating under ISO 22000-2018 has observed a marked increase in consumer complaints related to a specific product attribute. Concurrently, a recent regulatory update has imposed stricter limits on a parameter monitored at an existing critical control point, CCP, for this product. As the lead implementer, which of the following actions would be the most effective initial step to ensure compliance and mitigate the heightened risk associated with this CCP? Option A. Focus solely on retraining personnel responsible for monitoring the critical control point, assuming current equipment is adequate. Option B. Allocate additional resources, including enhanced monitoring equipment and increased personnel time for verification, to the identified critical control point. Option C. Initiate a review of all prerequisite programs to identify potential deficiencies that may be indirectly contributing to the issue. Option D. Propose the establishment of new critical control points within the process to address the increased regulatory scrutiny. The correct answer is B. Allocate additional resources, including enhanced monitoring equipment and increased personnel time for verification, to the identified critical control point. Explanation. The question asks to identify the most appropriate method for allocating resources when a food business has identified a critical control point, CCP, requiring enhanced monitoring and verification due to recent regulatory changes and an increase in consumer complaints. ISO 22000-2018, specifically Clause 8.5.2, addresses the establishment of prerequisite programs PRP and their role in supporting the HACCP plan. Clause 8.5.3 outlines the process of establishing the HACCP plan, including the identification of CCPs. Clause 7.1.3 focuses on infrastructure, which includes the necessary equipment, software, and facilities, and Clause 7.1.4 addresses the work environment. Resource allocation within a food safety management system is crucial for effective implementation and maintenance. When a CCP's criticality increases or new regulatory demands arise, it necessitates a review of existing resources and potentially an increase or reallocation. This might involve investing in more sophisticated monitoring equipment, increasing the frequency of testing, dedicating more personnel time to verification activities, or enhancing training for staff involved. Considering the scenario, the most direct and effective approach to address the heightened criticality of a CCP, especially in response to regulatory changes and increased complaints, is to ensure that the necessary resources are available and properly allocated. This aligns with the overall requirement of ISO 22000 to manage resources effectively to achieve food safety. The other options, while potentially related to resource management in a broader sense, do not directly address the immediate need to bolster resources for a specific, heightened risk CCP. For instance, revising PRPs might be a secondary consideration, but the primary action is to support the HACCP plan itself. Similarly, focusing solely on personnel training without ensuring adequate equipment or time allocation would be insufficient. Establishing new CCPs is not indicated by the scenario, as the problem focuses on an existing CCP. Therefore, the most appropriate action is to ensure adequate resources are allocated to the identified CCP. Question 17. When assessing the overall effectiveness of a food safety management system implemented in a large-scale dairy processing facility that adheres to ISO 22000-2018, which of the following sets of performance indicators would provide the most comprehensive and actionable insights into the system's operational conformity and its ability to achieve intended food safety outcomes? Option A. Rate of internal audit findings related to documentation completeness, percentage of pest control measures implemented as per schedule, and the number of external regulatory noncompliance notices received. Option B. Number of employee training hours on food safety, frequency of equipment calibration checks, and the volume of finished product recalled due to microbiological contamination. Option C. Percentage of critical control points, CCP, maintained within specified limits, number of validated prerequisite programs, PRP, with documented evidence of effectiveness, and the trend of allergen cross-contamination incidents per production batch. Option D. Average time taken to respond to customer complaints related to food safety, number of supplier audits conducted annually, and the total expenditure on food safety-related technologies. The correct answer is C. Percentage of critical control points, CCP, maintained within specified limits, number of validated prerequisite programs, PRP, with documented evidence of effectiveness, and the trend of allergen cross-contamination incidents per production batch. Explanation: the effectiveness of a food safety management system, FSMS, is determined by its ability to achieve its intended outcomes. ISO 22000-2018, specifically in Clause 9. 1. Mandates the monitoring, measurement, analysis, and evaluation of the FSMS performance. This clause emphasizes understanding what needs to be monitored and measured, the methods for monitoring, measurement, analysis, and evaluation, when to perform these activities, and when the results should be analyzed and evaluated. The objective is to ensure the FSMS is operating as intended and to identify areas for improvement. Performance indicators are crucial for this evaluation. They should be established based on the organization's objectives, the nature of its operations, and regulatory requirements. For instance, tracking the number of critical control points, CCP, that have deviated from their set parameters, the frequency of internal audit nonconformities related to prerequisite programs, or the timeliness of corrective actions for identified hazards are all valid performance indicators. The analysis and evaluation of these indicators provide insights into the FSMS conformity, effectiveness, and efficiency. This process directly supports the management review and drives continual improvement. The key is to select indicators that provide meaningful data relevant to food safety and the overall performance of the FSMS, ensuring that the chosen indicators are aligned with the organization's food safety policy and objectives. The evaluation of these indicators informs decisions about resource allocation and strategic direction for enhancing food safety. Question 18. Considering the foundational requirements for establishing a robust food safety management system, FSMS, according to ISO 22000-2018, what is the most critical initial step that dictates the breadth and applicability of all subsequent documented information, including hazard analysis and control plans? For multi-site food processing, conglomerate manufacturing diverse product lines ranging from dairy to baked goods. Option A. Implementing a rigorous record-keeping system to capture all operational data and verification activities from the outset of FSMS design. Option B. Conducting a thorough hazard identification and risk assessment for every single raw material and finished product across all operational sites simultaneously. Option C. Establishing the precise scope of the FSMS, clearly delineating which sites, product categories, and operational activities are included within its application. Option D. Developing a comprehensive food safety manual that details all organizational processes and procedures in a singular, overarching document. Correct answer is C. Establishing the precise scope of the FSMS, clearly delineating which sites, product categories, and operational activities are included within its application. Explanation: the development of a food safety management system, FSMS documentation, as per ISO 22000-2018, requires a structured approach that considers the organization's context, complexity, and the specific food products and processes involved. Clause 4. 3 of the standard mandates the determination of the FSMS scope. This scope defines the boundaries and applicability of the FSMS within the organization, considering external and internal issues. Clause 4. 1. The needs and expectations of interested parties. Clause 4. 2. And the products and services. The scope statement is a foundational document that influences all subsequent documentation, including the food safety policy, objectives, and the procedures for hazard analysis and control. Without a clearly defined scope, it becomes challenging to determine which processes, products, and locations are covered by the FSMS, leading to potential gaps in hazard identification, risk assessment, and the implementation of prerequisite programs, PRP, and operational prerequisite programs, OPP. Therefore, the determination of the FSMS scope is a prerequisite for effectively developing and implementing the entire documentation structure. Question 19. A global food processing company specializing in dairy products is undergoing an ISO 22000-2018 audit. The auditors are scrutinizing the effectiveness of the implemented control measures for Listeria monocytogenes in their cheese production lines. The company has established rigorous prerequisite programs and identified critical control points, CCP, and operational prerequisite programs, OPP, to mitigate this hazard. During the audit, the auditors request documented evidence demonstrating that these implemented control measures are scientifically sound and capable of achieving the intended food safety objectives. Which specific requirement within ISO 22000-2018 most directly addresses the need for such documented scientific validation of control measures? Option A, 8.2 Traceability system. Option B, 8.7 Control of monitoring and measuring equipment. Option C, 8.3 Control of nonconformities. Option D, 8.5 Validation of the prerequisite programs and of the measures and combinations of measures identified by the hazard analysis. The correct answer is D, 8.5 Validation of the prerequisite programs and of the measures and combinations of measures identified by the hazard analysis. Explanation. The core of ISO 22000-2018 is the integration of HACCP principles with prerequisite programs, PRP, and the Plan Do Check Act, PDCA cycle. Clause 8, Operation, specifically details the implementation of food safety management system processes. Within Clause 8, Subclause 8, 2, Traceability system, mandates that an organization shall establish and implement a system to identify and trace all food ingredients, intermediate products, and finished products. This traceability is crucial for effective recall management and for demonstrating compliance with regulatory requirements, such as those from the European Food Safety Authority, EFSA, or the U.S. Food and Drug Administration, FDA, which often require robust traceability to manage food safety incidents. Subclause 8.3 Control of nonconformities addresses how to handle situations where a product or process does not conform to food safety requirements. This includes segregation, containment, and disposition of nonconforming products, as well as taking corrective actions to prevent recurrence. Subclause 8.5 Validation of the prerequisite programs and of the measures and combinations of measures identified by the hazard analysis is critical because it requires documented evidence that PRPs and control measures are effective in controlling identified food safety hazards. This validation process is often based on scientific literature, expert opinion, or empirical data, and is distinct from verification, which confirms that the system is operating as intended. Subclause 8.7 Control of monitoring and measuring equipment ensures that equipment used for monitoring food safety parameters is calibrated and maintained to ensure accuracy. Therefore, while all clauses are important, the validation of PRPs and control measures, 8.5, directly addresses the scientific and technical basis for the food safety controls in place, a key requirement for demonstrating the effectiveness of the system. Question 20. Consider a food processing facility producing a ready-to-eat product that undergoes a pasteurization step designed to eliminate a specific bacterial pathogen. During the hazard analysis, it's determined that this pathogen can be present in the raw ingredients and, if not adequately controlled, can survive the pasteurization process if the temperature or time parameters are not precisely maintained. A subsequent chilling step is in place to prevent pathogen growth. Which of the following represents the most critical factor in determining whether the pasteurization step itself should be classified as a critical control point, CCP, according to ISO 22000-2018 principles? Option A, the overall complexity of the pasteurization equipment and the frequency of its maintenance checks. Option B, the presence of the bacterial pathogen in the raw ingredients, irrespective of the pasteurization process's effectiveness. Option C, the proven ability of the pasteurization process, when operated within specified parameters, to effectively reduce or eliminate the identified bacterial pathogen to an acceptable level. Option D, the ability of the subsequent chilling step to inhibit the growth of any surviving bacteria, even if the pasteurization is suboptimal. Correct answer is C, the proven ability of the pasteurization process, when operated within specified parameters, to effectively reduce or eliminate the identified bacterial pathogen to an acceptable level. Explanation: the identification of critical control points, CCP, within a food safety management system, as guided by ISO 22000-2018, involves a systematic hazard analysis and the subsequent application of decision trees. A CCP is a step at which control can be applied and is essential to prevent or eliminate a food safety hazard or reduce it to an acceptable level. The decision tree, a tool recommended in Annex of ISO 22000-2018, helps determine if a control point is a CCP. The core principle is to ask a series of questions to assess the necessity and effectiveness of control at a given step. For instance, if a hazard is present at a specific step, and control at this step is necessary to prevent or reduce the hazard to an acceptable level, and if this control is likely to be effective in achieving the food safety objective, then it qualifies as a CCP. The process requires a deep understanding of the food production process, potential hazards, and the efficacy of proposed control measures. It is not about simply eliminating a hazard, but about controlling it to an acceptable level. The effectiveness of the control measure is paramount in this determination. Therefore, the critical consideration when deciding if a control point becomes a CCP is the likelihood that the control measure implemented at that point will successfully manage the identified food safety hazard to a level that does not pose an unacceptable risk to the consumer. Question 21. When initiating the development of an ISO 22000-2018 compliant food safety management system for a new food processing facility specializing in chilled ready-to-eat meals, what is the most critical initial action to undertake to establish a baseline for implementation and ensure alignment with regulatory mandates such as the U.S. Food and Drug Administration's FDA Preventive Controls for Human Food Rule, which influences prerequisite program design? Option A, train all personnel on general food safety principles and the company's vision for a food safety culture without a structured assessment of existing practices against the standard. Option B, immediately develop and implement all prerequisite programs, PRP, as outlined in ISO 22000-2018, assuming that compliance with regulatory standards will be inherently achieved. Option C, focus solely on establishing the HACCP plan, as it is the core of any food safety system, and address other ISO 22000-2018 requirements subsequently. Option D, conduct a comprehensive gap analysis to identify all deviations between current operational practices and the specific requirements of ISO 22000-2018, cross-referencing these with applicable national and international food safety regulations. The correct answer is D. Conduct a comprehensive gap analysis to identify all deviations between current operational practices and the specific requirements of ISO 22000-2018, cross-referencing these with applicable national and international food safety regulations. Explanation: the initial step in developing a robust food safety management system, FSMS, according to ISO 22000-2018, particularly when transitioning from a non-certified state or an older standard, is a comprehensive gap analysis. This process systematically identifies the discrepancies between the organization's current practices and the requirements stipulated by the ISO 22000-2018 standard. A critical component of this analysis is not just identifying what is missing, but also understanding the underlying reasons for these gaps. For instance, a gap in documented prerequisite programs, PRP, might stem from a lack of awareness of specific regulatory requirements, insufficient staff training, or an absence of dedicated resources. Similarly, a deficiency in hazard identification and risk assessment for a particular process could be due to inadequate expertise in hack principles or a failure to integrate relevant scientific data. The analysis must also consider the interaction between different clauses of the standard, such as how the management of change clause impacts the hazard analysis and PRP review. The outcome of this analysis forms the foundation for the FSMS implementation plan, prioritizing actions based on risk and the criticality of meeting standard requirements. It's essential to link these identified gaps to specific clauses within ISO 22000-2018, such as Clause 8. 2. Hazard analysis, or Clause 7. 2. Competence, to ensure a structured and compliant approach to remediation. The ultimate goal is to map out a clear path to full conformity, ensuring all aspects of the standard are addressed in a systematic and effective manner. Question 22. A food processing company operating under a robust ISO 22000-2018 certified food safety management system has observed a statistically significant increase in the frequency of internal nonconformities related to inadequate sanitation procedures in their packaging area over the last quarter. Analysis of related customer feedback data also indicates a minor uptick in product contamination, complaints specifically linked to visual debris in packaged goods. As the lead implementer, which strategic approach best leverages this combined data to drive systemic improvement in accordance with ISO 22000-2018 principles? Option A. Initiate an external audit of the entire food safety management system, as a widespread breakdown in control is indicated by the dual data streams, necessitating a comprehensive external assessment. Option B. Conduct a root cause analysis of the sanitation nonconformities, correlate findings with customer feedback trends, and implement targeted retraining and enhanced verification protocols for packaging area personnel, followed by a review of the effectiveness of these actions. Option C. Focus solely on enhancing the customer feedback collection mechanism to gather more detailed information, as this is the primary indicator of system failure according to ISO 22000-2018. Option D. Immediately revise the hazard analysis and critical control points, HACP, plan for the packaging stage to include additional CCPs for visual debris inspection, assuming the current CCPs are insufficient. The correct answer is B. Conduct a root cause analysis of the sanitation nonconformities, correlate findings with customer feedback trends, and implement targeted retraining and enhanced verification protocols for packaging area personnel, followed by a review of the effectiveness of these actions. Explanation. ISO 22000-2018 emphasizes a data-driven approach to food safety management, requiring organizations to establish processes for monitoring, measurement, analysis, and evaluation. Clause 9.1 outlines the need to determine what needs to be monitored and measured, the methods for monitoring, measurement, analysis, and evaluation, when monitoring and measurement should be performed, and when the results of monitoring and measurement should be analyzed and evaluated. Clause 9.1.3 specifically addresses analysis and evaluation of data, requiring the organization to analyze and evaluate appropriate data and information arising from the monitoring and measurement activities to evaluate the performance and the effectiveness of the food safety management system. This analysis should identify trends and patterns that can inform corrective actions and drive continuous improvement. When considering feedback from various sources, such as customer complaints, audit findings, and internal monitoring results, a lead implementer must ensure that the analysis goes beyond simply identifying the problem. It should aim to understand the root causes and assess the effectiveness of implemented controls. For example, if customer complaints regarding undeclared allergens are increasing, the analysis should not only identify the specific products and batches involved, but also investigate the upstream processes, supplier controls, and internal verification steps that may have contributed to the issue. The evaluation of this data should then lead to targeted improvements in the food safety management system, such as enhanced supplier auditing protocols, more rigorous in-process allergen testing, or improved labeling verification procedures. The objective is to use this information to prevent recurrence and enhance overall food safety assurance. Question 23. A food manufacturer specializing in prepackaged salads has experienced a confirmed outbreak of E. coli O157, H7 linked to a specific batch of spinach. The ISO 22000-2018 lead implementer is tasked with evaluating the effectiveness of the company's traceability system. The system uses lot numbers for incoming raw materials and a sequential batch code for finished products. During a simulated recall exercise, it took the team 4 hours to identify all retail locations that received the affected salad batches, and an additional 3 hours to pinpoint the specific supplier lot of spinach used in those batches. Considering the principles of ISO 22000-2018, what is the primary deficiency demonstrated by this scenario in the organization's traceability system? Option A. The system's reliance on sequential batch coding for finished products is inherently flawed for rapid recall identification. Option B. Insufficient validation of the traceability system, indicating a lack of preparedness for actual food safety incidents. Option C. Inadequate integration of lot-specific raw material identification with finished product batch coding, leading to prolonged identification times during a recall. Option D. The 4-hour identification of retail locations and 3-hour pinpointing of the spinach supplier lot are within acceptable timeframes for a recall. The correct answer is C. Inadequate integration of lot-specific raw material identification with finished product batch coding, leading to prolonged identification times during a recall. Explanation: the core of a robust traceability system within ISO 22000-2018 is its ability to provide a clear, step-by-step linkage from raw materials to the final product delivered to the consumer, and vice versa. This involves documenting critical control points, processing parameters, and distribution chains. When a food safety incident occurs, such as the detection of a specific pathogen in a batch of finished product, the organization must be able to quickly identify all affected products and their locations. This is achieved by tracing forward, identifying where the affected product went, and tracing backward, identifying the source of the contaminated ingredient or process deviation. The effectiveness of the system is measured by the speed and accuracy with which it can isolate the problem, thereby minimizing the scope of recalls, reducing potential health risks, and protecting the organization's reputation. A key element is the establishment of unique identification codes for raw materials, intermediate products, and finished goods, which are consistently applied throughout the production and supply chain. Furthermore, the system must be validated periodically to ensure its continued effectiveness and compliance with relevant regulatory requirements, such as those mandated by food safety authorities like the FDA or EFSA, which often specify minimum traceability requirements for certain food categories. The ability to conduct mock recalls is a practical demonstration of the system's functionality. Question 24. A dairy product manufacturer, certified to ISO 22000-2018, observes a consistent month-over-month increase in customer complaints, specifically citing the presence of undeclared peanut traces in their lactose-free milk products. Analysis of internal records indicates no changes in raw material suppliers or processing equipment during the period of the increase. Food safety team is tasked with determining the most appropriate immediate action to address this escalating issue, considering the principles of hazard control and continuous improvement mandated by the standard. Which of the following actions would be the most effective initial step for the food safety team to undertake? Option A. Expand the scope of finished product testing to include random sampling for peanut allergens across all product lines, irrespective of their declared ingredients. Option B. Conduct a thorough reevaluation of the existing allergen control procedures and their implementation effectiveness, focusing on the handling and segregation of allergenic ingredients throughout the production process. Option C. Revise the existing hack plan to include additional critical control points for allergen detection, even without identifying specific procedural failures. Option D. Immediately initiate a comprehensive retraining program for all production and quality control personnel on allergen awareness and handling protocols. The correct answer is B. Conduct a thorough reevaluation of the existing allergen control procedures and their implementation effectiveness, focusing on the handling and segregation of allergenic ingredients throughout the production process. Explanation: the scenario describes a food processing facility that has identified an upward trend in the number of customer complaints related to undeclared allergens in their finished products. The ISO 22000-2018 standard mandates that an organization shall establish, implement, and maintain a food safety management system. This includes ensuring that processes are in place to identify, evaluate, and control food safety hazards. When analyzing data, particularly concerning customer feedback and product nonconformities, a lead implementer must consider the root causes and the effectiveness of existing control measures. In this context, the increase in allergen-related complaints directly points to a potential breakdown or inadequacy in the allergen control program. This program is a critical component of the Hazard Control Plan, which is a cornerstone of ISO 22000. The standard requires that the organization review the hazard analysis and the hazard control plan at planned intervals or when changes occur. The increasing complaint trend signifies a need for such a review. The most effective immediate action, as per the principles of continuous improvement embedded in ISO 22000, is to reevaluate the effectiveness of the current allergen control measures. This involves scrutinizing the procedures for ingredient sourcing, verification of supplier declarations, handling and storage of allergenic materials, and the accuracy of product labeling. The objective is to identify the specific points of failure that are leading to the undeclared allergens reaching the consumer. This proactive approach aligns with the management system's commitment to preventing issues before they escalate and ensuring the safety of the food supplied. Other options, while potentially part of a broader corrective action process, do not represent the most direct and effective first step in addressing this specific data trend within the framework of ISO 22000. For instance, solely focusing on retraining staff without understanding the specific procedural gaps might not resolve the core issue. Similarly, updating the HAC plan without a thorough review of the allergen control implementation might miss critical operational failures. Broadening the scope of product testing without pinpointing the source of the allergen contamination is also less efficient than targeted reevaluation. Question 25. Consider a poultry processing facility implementing ISO 22000-2018. The FSMS requires documented work instructions for the critical control point, CCP, of chilling cooked chicken to a specified internal temperature within a defined timeframe to prevent microbial growth. Which aspect of these work instructions would be most crucial for ensuring consistent and effective control of this CCP in alignment with the standard's intent for operational control? Option A. Detailed steps for temperature measurement, the acceptable range for internal temperature, the maximum time allowed for chilling, the personnel authorized to perform the chilling and monitoring, and the procedure for recording results and addressing any deviations from the specified parameters. Option B. A historical record of past chilling temperatures, without explicit instructions on how to conduct current chilling operations. Option C. A list of all equipment used in the chilling process, along with their maintenance schedules, but no specific instructions on how to operate them for food safety control. Option D. A general overview of the chilling process, emphasizing the importance of food safety without specifying exact temperature thresholds or time limits. The correct answer is A. Detailed steps for temperature measurement, the acceptable range for internal temperature, the maximum time allowed for chilling, the personnel authorized to perform the chilling and monitoring, and the procedure for recording results and addressing any deviations from the specified parameters. Explanation: the effectiveness of documented work instructions in a food safety management system, FSMS, under ISO 22000-2018 hinges on their ability to ensure consistent execution of critical food safety tasks, thereby controlling identified hazards. Clause 7.5. One of ISO 22000-2018 mandates that the organization shall maintain documented information to the extent necessary to support the operation of the FSMS. This includes documented information required by the standard and documented information determined by the organization as necessary for the effectiveness of the FSMS. When considering work instructions for tasks such as critical control point, CCP monitoring, or prerequisite program, PRP verification, the focus must be on providing clear, unambiguous, and actionable guidance. The instructions should detail the specific steps to be performed, the frequency of execution, the personnel responsible, the methods for recording results, and the actions to be taken in case of deviations. This ensures that personnel can reliably perform their duties, contributing to hazard control and overall food safety. The primary purpose is to establish a baseline for consistent performance, facilitate training, and provide a basis for verification and validation activities. Therefore, work instructions that clearly define the what, how, when, and who for critical food safety activities, including the necessary corrective actions for deviations, are most effective in supporting the FSMS operational control. Question 26. an organization specializing in artisanal cheese production, operating under strict EU regulations for raw milk products, identifies a significant risk of Listeria monocytogenes contamination due to potential temperature fluctuations during the aging process in their new, partially climate-controlled cellar. They also recognize an opportunity to expand their market share by obtaining a halal certification, which would require modifications to their ingredient sourcing and processing. As the lead implementer, what is the most effective initial approach to integrate the actions for addressing these identified risks and opportunities within their existing food safety management system, FSMS, according to ISO 22000-2018? Option A. Focus solely on mitigating the Listeria risk by implementing additional sanitation steps, deferring the halal certification opportunity until the primary risk is fully contained and validated. Option B. Conduct a comprehensive review of all existing control measures and prerequisite programs to identify potential gaps, and then systematically plan actions for both the Listeria risk and the halal opportunity, ensuring alignment with the organization's food safety policy and objectives. Option C. Develop specific control measures for Listeria, including enhanced temperature monitoring and validation of cleaning procedures, and create a project plan for halal certification, ensuring both are documented and integrated into the FSMS operational procedures and management review processes. Option D. Immediately implement new hack plans for both Listeria control and halal compliance, updating all relevant prerequisite programs and providing extensive staff training without further risk assessment. The correct answer is C. Develop specific control measures for Listeria, including enhanced temperature monitoring and validation of cleaning procedures, and create a project plan for halal certification, ensuring both are documented and integrated into the FSMS operational procedures and management review processes. Explanation: the core principle of addressing risks and opportunities in ISO 22000-2018 is proactive management to achieve intended outcomes and prevent undesirable effects. Clause 6. 1. Actions to address risks and opportunities mandates that an organization shall plan actions to address these risks and opportunities. This involves determining what needs to be done to eliminate the threat of hazards and enhance opportunities for food safety, considering the context of the organization, its objectives, and the requirements of the standard. The planning process should identify potential risks, e.g., contamination, process failures, and opportunities, e.g., new market segments, improved efficiency. For each identified risk, appropriate control measures are to be established, implemented, and maintained. Similarly, opportunities should be leveraged to improve the food safety management system. The effectiveness of these actions must be evaluated. Crucially, the standard emphasizes integrating these actions into the food safety management system processes, ensuring they are not treated as isolated activities. This integration supports the overall goal of enhancing the effectiveness of the FSMS and achieving desired improvements in food safety performance. The organization must also determine how to integrate and implement the actions into the FSMS and how to evaluate their effectiveness. This systematic approach ensures that the organization is not merely reacting to issues, but is strategically managing its food safety landscape. Question 27. A multinational food processing company, Global Harvest Foods, has implemented an ISO 22000-2018 certified food safety management system. During a recent internal audit, several minor deviations were noted in the temperature monitoring records for chilled storage units across different facilities. While no immediate safety risk was identified, the audit report highlighted a lack of consistent root cause analysis for these recurring temperature fluctuations. The company's lead implementer is tasked with proposing a strategy to address this and foster a culture of proactive improvement. Which of the following approaches best exemplifies the principles of continual improvement as mandated by ISO 22000-2018 in this scenario? Option A. Update the FSMS documentation to include a new prerequisite program specifically for temperature control, detailing enhanced calibration schedules for temperature monitoring devices without further investigation into past deviations. Option B. Commission an external consultant to perform a comprehensive review of the entire FSMS, focusing on identifying potential systemic weaknesses and recommending broad strategic changes across all operational areas. Option C. Issue a directive to all facility managers to ensure stricter adherence to existing temperature monitoring protocols and conduct immediate retraining on record-keeping accuracy for all relevant personnel. Option D. Establish a cross-functional team to conduct thorough investigations into the root causes of temperature deviations, implement corrective actions, and monitor the effectiveness of these actions through enhanced data analysis and periodic reassessments of the monitoring procedures. The correct answer is D. Establish a cross-functional team to conduct thorough investigations into the root causes of temperature deviations, implement corrective actions, and monitor the effectiveness of these actions through enhanced data analysis and periodic reassessments of the monitoring procedures. Explanation: ISO 22000-2018 mandates a systematic approach to food safety management, emphasizing continual improvement. Clause 10, improvement, outlines the core requirements. Specifically 10, 1. Nonconformity and corrective action, and 10, 2. Continual improvement are crucial. Continual improvement in a food safety management system, FSMS, involves proactively identifying opportunities to enhance the effectiveness of the FSMS and its ability to deliver safe food. This is achieved through a PDCA, Plan Do Check Act, cycle, leveraging data from monitoring, audits, management reviews, and feedback. The objective is to increase the likelihood of meeting food safety objectives and regulatory requirements. A key element is the systematic analysis of information gathered to identify trends, root causes of issues, and areas where performance can be elevated. This analysis informs decisions on implementing changes, which could involve revising procedures, updating prerequisite programs, enhancing control measures, or improving training. The effectiveness of these implemented changes is then evaluated, creating a feedback loop for further refinement. This iterative process ensures the FSMS remains robust and responsive to evolving risks and operational realities, aligning with the overall goal of preventing foodborne illnesses and ensuring consumer confidence. Question 28. Consider a food processing facility producing prepackaged salads. During a hazard analysis workshop, the team identifies that certain batches of lettuce may contain trace amounts of a pesticide residue above the legal limit set by the National Food Regulatory Authority, such as the European Food Safety Authority, EFSA, or the U.S. Food and Drug Administration, FDA. The team also notes that the specific pesticide is known to cause neurological effects at high exposure levels, though the identified trace amounts are significantly below levels that would cause acute toxicity. The process involves washing, chopping, and packaging the lettuce. Which of the following actions best reflects the application of ISO 22000-2018 principles for managing this identified chemical hazard? Option A. Implement enhanced supplier verification procedures focusing on pesticide testing of incoming lettuce. Establish a critical limit for pesticide residue based on the legal maximum residue level, MRL, and monitor this limit at a critical control point, CCP, before chopping. Option B. Focus solely on improving the general hygiene practices throughout the facility, believing that overall cleanliness will mitigate the risk of pesticide contamination without specific monitoring. Option C. Immediately halt all production of prepackaged salads until the source of the pesticide residue is completely eliminated, as any detectable level is unacceptable. Option D. Document the presence of the pesticide residue as a potential hazard, but decide not to implement a specific control measure, assuming the washing process will sufficiently dilute it to safe levels. The correct answer is A. Implement enhanced supplier verification procedures focusing on pesticide testing of incoming lettuce. Establish a critical limit for pesticide residue based on the legal maximum residue level, MRL, and monitor this limit at a critical control point, CCP, before chopping. Explanation: the effectiveness of a food safety management system under ISO 22000-2018 hinges on the systematic identification and control of food safety hazards. Clause 8.5.2 Hazard analysis mandates that an organization shall establish a hazard analysis process. This process involves identifying potential food safety hazards, biological, chemical, and physical, that may be reasonably expected to occur in relation to the type of food and the processes. It also requires considering potential contamination from raw materials, ingredients, process aids, packaging materials, and any other materials that come into contact with the food. Furthermore, the organization must evaluate the likelihood of occurrence and the severity of the potential adverse health effects of identified hazards. The subsequent step, determining control measures, Clause 8.5, 3. Involves selecting and implementing control measures to ensure that the food safety risk is managed to an acceptable level. This selection is based on the hazard analysis. For a lead implementer, understanding that not all identified hazards will necessitate a control measure, the decision is based on the risk assessment, likelihood, and severity. The identification phase is crucial, but the subsequent evaluation and selection of control measures are where the system's practical application is realized. Therefore, a scenario focusing on the initial identification of a hazard without a clear path to control or a misinterpretation of the evaluation process would highlight a misunderstanding of the core hazard analysis and control measure selection principles. The critical element is the systematic approach to both identifying and then managing these hazards through appropriate control measures based on the risk they present. Question 29. A food manufacturer producing ready-to-eat deli meats identifies Listeria monocytogenes as a significant food safety hazard that can be introduced during the slicing and packaging process. After conducting a thorough hazard analysis, the company determines that a specific heat treatment step, validated to reduce the population of Listeria monocytogenes to a level below the acceptable limit as per regulatory requirements, e.g., Regulation EC No. 2073/2005, is critical. If this heat treatment fails to achieve the specified reduction, the product would present an unacceptable risk of Listeria monocytogenes contamination. Which category of control measure best describes this heat treatment step within the framework of ISO 22000-2018? Option A. Operational Prerequisite Program (OPP). Option B. Hazard Control Measure (HCM). Option C. Critical Control Point (CCP). Option D. Prerequisite Program (PRP). Correct answer is C. Critical Control Point (CCP). Explanation. The identification and control of food safety hazards is a cornerstone of ISO 22000-2018. The standard differentiates between prerequisite programs (PRP), operational prerequisite programs (OPP), and critical control points (CCP). PRPs establish the fundamental environmental and operational conditions necessary for producing safe food. OPP are control measures identified through hazard analysis that are necessary to control the likelihood of introducing a food safety hazard or the amplification of a food safety hazard to an unacceptable level. They are distinguished from CCPs by the fact that their control is necessary, but the absence of control does not necessarily lead to an unacceptable risk. Rather, it increases the likelihood of an unacceptable risk. CCP, on the other hand, are steps where control is essential to prevent or eliminate a food safety hazard or reduce it to an acceptable level. The key differentiator for a CCP is that failure to control it would result in a significant food safety risk. In the context of pasteurization, if the temperature and time parameters are precisely defined and validated to eliminate a specific pathogen, and any deviation below these parameters would directly lead to an unacceptable level of that pathogen, then it functions as a CCP. If the pasteurization process is designed with a safety margin, or if other control measures are in place that would mitigate the risk of pathogen survival even with minor deviations in pasteurization, it might be classified as an OPP. The scenario describes a situation where the absence of adequate pasteurization directly leads to an unacceptable risk of Listeria monocytogenes contamination, indicating that this step is critical for preventing or reducing the hazard to an acceptable level. Therefore, it is a CCP. Question 30. A global food manufacturer, operating under ISO 22000-2018, faces a challenge where their internal audit findings indicate inconsistencies in allergen detection results across different production lines. The audit report highlights that the laboratory equipment used for testing is within its warranty period, but has not undergone any formal calibration verification since its initial installation 6 months ago. The organization's food safety policy emphasizes a commitment to continuous improvement and hazard control. Considering the requirements of ISO 22000-2018, what is the most critical immediate action the lead implementer should recommend to address this nonconformity and ensure ongoing compliance? Option A. Request a replacement of the laboratory equipment from the supplier, citing potential inherent defects affecting accuracy. Option B. Conduct a root cause analysis to determine if the detected inconsistencies are due to operator error rather than equipment malfunction. Option C. Review and update the prerequisite programs to include more stringent manual checks for allergen cross-contamination on production lines. Option D. Immediately initiate a comprehensive calibration verification program for all allergen detection laboratory equipment, ensuring traceability to national or international standards. The correct answer is D. Immediately initiate a comprehensive calibration verification program for all allergen detection laboratory equipment, ensuring traceability to national or international standards. Explanation: the core of ensuring compliance with ISO 22000-2018 lies in the systematic integration and verification of its clauses within an organization's operational framework. Clause 8, Operation, is particularly critical as it details the implementation of the Food Safety Management System. Within this clause, 8.5.3, Control of monitoring and measuring equipment, mandates that equipment used for food safety monitoring must be suitable for its intended purpose and calibrated or verified at specified intervals. This ensures the reliability of data used for decision-making, including the validation of control measures. Without proper calibration, the effectiveness of critical control points, CCP, or operational prerequisite programs, OPP, cannot be assured, potentially leading to noncompliance. Therefore, establishing and maintaining a robust calibration program for all food safety monitoring equipment is a fundamental requirement for demonstrating conformity to ISO 22000-2018 and ensuring the integrity of the food safety system. This process directly supports the overall objective of providing safe food by guaranteeing the accuracy of the measurements used to control hazards.